Hi everyone. This lesson will provide you with an understanding of the essential items required for building, testing, and maintaining electronic and electrical systems. Knowing how to properly use these tools and materials is crucial for ensuring safety, efficiency, and success in your projects. Let's explore the various tools, materials, and equipment that you will encounter and learn how to use them effectively. Combination pliers are a fantastic tool because they can do so many things. Imagine having one tool that can grip things tightly, bend metal, cut through wires, and even strip the plastic coating off wires. That's what combination pliers can do. These pliers are incredibly useful in many situations. For example, if you're working on an electrical project and you need to connect two wires, you can use combination pliers to twist the wires together securely. This makes sure the connection is strong and safe. Fun fact, did you know that combination pliers are also called lineman's pliers? This is because electrical linemen, who work on power lines, use them a lot. They're so handy that professionals rely on them every day. Remember, always be careful when using tools like combination pliers. Make sure you know how to use them safely and always have an adult supervision if you're working on something electrical. Diagonal pliers are special cutting tools. They are designed to cut through wires and small metal pins, especially in tight spaces where bigger tools can't reach. Imagine you're working on a small electronic project, like building a robot or fixing a remote control. You often need to cut wires very close to other components without damaging anything else. Diagonal pliers are perfect for this job. Fun fact, diagonal pliers are sometimes called side cutters because of the way their jaws cut from the side. This design helps make very clean and precise cuts, which is why they are so popular in electronics work. Remember, when using diagonal pliers, always be cautious. Make sure you're cutting the right wire and not something important. Long nose pliers have long, thin jaws that taper to a point. This unique design allows them to grip small objects and bend wire with precision. Imagine you're working on an electronic project, and you need to form loops at the ends of wires to make connections. Long nose pliers make it easy to bend the wire into a neat loop. They're also great for reaching into tight spots, like behind other components on a circuit board, to grab or adjust something. Fun fact, did you know that jewelers and electricians often use long nose pliers? Their precise control makes them ideal for delicate work. Remember, because their tips are so thin, you don't want to apply too much pressure, or they might bend. Pull-push rule. It's a flexible ruler made of metal or plastic that can be extended to measure things and then retracted back into its case when you're done. This makes it super easy to carry around and store. Suppose you're designing a small robot. You need to make sure all the parts fit inside the body of the robot. You can use the pull-push rule to measure each part and the space available. This way, you can plan your design carefully and avoid any mistakes. Fun fact. Did you know that tape measures can have different lengths? Some are just a few feet long, while others can extend up to 100 feet or more. This makes them versatile for all kinds of projects, big or small. Remember, when using a pull-push rule, always pull out the tape slowly to avoid snapping it back too quickly, which can damage the tape or the case. And always double-check your measurements to ensure accuracy. An analog multimeter is a device that helps you measure three key electrical properties: voltage, current, and resistance. Unlike digital multimeters, which use a digital display, analog multimeters have a needle and dial that show the readings. Imagine you're trying to fix a circuit board, and something isn't working right. You can use an analog multimeter to measure the voltage at different points on the board. If you find a spot where the voltage is lower than it should be, that might indicate a problem like a bad connection or a faulty component. You can also use it to check continuity, which helps you see if electricity can flow through a wire or a trace on the board without any breaks. Fun fact, did you know that the first multimeters were created in the 1920s? Engineers needed a way to combine multiple measurement tools into one, and that's how the multimeter was born. Remember, always be careful when using an analog multimeter. Make sure you know what you're measuring and that your device is set to the correct setting. It's also important to handle the probes carefully to avoid any short circuits or accidental shocks. A digital multimeter, or DMM, is a device that helps you measure electrical properties like voltage, current, and resistance. Unlike the analog multimeter, which uses a needle and dial, the digital multimeter displays measurements as numbers on an LCD screen. Fun fact: did you know that digital multimeters are more accurate than their analog counterparts? This is because they provide exact numerical readings, reducing the chance of human error when reading the values. Digital multimeters are very useful because they give you precise and easy-to-read measurements. This makes troubleshooting and testing electrical circuits much simpler, especially for beginners. Remember, when using a digital multimeter, always ensure you're on the correct setting for what you're measuring. Handle the probes carefully and never measure high voltages without proper knowledge and safety precautions. A screwdriver is a tool that you use to drive screws into materials. It can also be used to remove screws. Screwdrivers are essential for assembling and disassembling electronic devices. For example, if you want to open a computer case to upgrade its components or secure a PCB inside an electronic device, you'll need a screwdriver. There are several types of screwdriver tips, each designed for different kinds of screws. Let's go over some common ones. Flat or slotted tip. This has a straight, flat edge and is used for screws with a single slot. It's one of the oldest and simplest types. Square tip. This tip is square-shaped and fits into screws with a square recess. It provides a good grip and is less likely to slip out. Phillips tip. This is the most common type, with a cross-shaped tip. It fits into screws with a cross recess and is used in many electronic devices and household items. Posa-drive tip. Similar to the Phillips tip but with additional lines, providing more grip and reducing the risk of the tool slipping out. It's commonly used in Europe. Torx tip. This tip is star-shaped and fits into screws with a star-shaped recess. It's often used in electronics, automotive, and mechanical applications because it provides excellent torque without slipping. Hex tip. This tip has a hexagonal shape and fits into screws with a hexagonal recess. It's often used for assembling furniture and mechanical parts. Fun fact: did you know that the invention of the Phillips screwdriver and screw significantly improved the speed of assembly in manufacturing, especially for automobiles? Remember, always use the correct type of screwdriver for the screw you're working with. Using the wrong type can damage the screw head and make it difficult to remove. A breadboard is a special board used to build and test electronic circuits without the need for soldering. This means you can easily insert and remove components as you design and modify your circuit. A breadboard is a rectangular board with many tiny holes in it. These holes are connected internally in a way that lets you create a circuit just by plugging in wires and components. Imagine you're designing a new electronic gadget, like a simple alarm system. You can use a breadboard to build the circuit first, testing each part to make sure it works correctly. If you need to change something, you can easily move the components around on the breadboard. This saves you a lot of time and effort compared to soldering everything permanently. Fun fact: the term breadboard comes from the early days of electronics when people would use literal wooden boards to mount their electronic components for prototyping. Remember, when using a breadboard, make sure to insert the components firmly into the holes so they make good electrical contact. It's also a good idea to keep your wires neat and organized to avoid confusion as your circuits get more complex. An electric drill is a tool powered by electricity that is used to make holes in various materials, such as wood, metal, plastic, and more. It can also be used to drive screws and other fasteners. Electric drills are incredibly useful for a wide range of tasks. In the context of electronics, you might need to mount components onto a surface or create enclosures for your projects. An electric drill makes these tasks quick and easy. Fun fact: did you know that the first electric drill was invented in 1889? It was much larger and heavier than the ones we use today, but it revolutionized the way holes were made in various materials. Remember, when using an electric drill, always wear safety goggles to protect your eyes from debris. Make sure to hold the drill steady and apply consistent pressure to avoid damaging your materials or the drill bit. A mini drill is a smaller, more precise version of a regular drill. It's designed for detailed work where accuracy is important, such as drilling tiny holes in materials like copper-clad laminate. Mini drills are perfect for working on detailed projects where larger drills would be too clumsy. They are especially useful in electronics for creating precise holes in PCBs. Fun fact: did you know that mini drills are also used by hobbyists and model makers? Their precision makes them perfect for delicate and intricate work, such as making models or detailed art pieces. Remember, when using a mini drill, make sure to work slowly and carefully. Because the drill bits are so small, they can break easily if you apply too much pressure. Tweezers are small tools that are used to pick up and handle tiny objects. They have two arms that you squeeze together to grip small components, making them very useful in delicate tasks. You can use it to place a tiny resistor or capacitor in the correct spot. Using your fingers might be too clumsy and could damage the component or the board. Tweezers allow you to pick up the small component and place it exactly where it needs to go. Point 33. Fun fact: did you know that tweezers have been used for thousands of years? Ancient Egyptians used versions of tweezers for personal grooming and medical procedures. Remember, when using tweezers, handle them gently to avoid crushing delicate components. Always work in a well-lit area so you can see what you're doing clearly. And keep your tweezers clean to ensure they grip properly. A wire stripper is a tool designed to safely and easily remove the plastic insulation from electrical wires, exposing the metal conductor inside. When you're working on an electronic project, you often need to connect wires to various components. To make these connections, you need to remove the insulation from the ends of the wires. A wire stripper makes this job quick and precise, ensuring you don't damage the wire. Fun fact: did you know that using a knife or scissors to strip wires can be dangerous and often damages the wire? That's why wire strippers are specially designed to do the job safely and accurately. Remember, when using a wire stripper, choose the correct notch for the wire gauge you're working with. Gently squeeze the handles, rotate the tool slightly around the wire, and then pull off the insulation. Always be careful to avoid nicking the wire, which can weaken it. A soldering iron is a tool that heats up to melt solder, a special metal that is used to join electrical components together. The melted solder flows around the components and then cools to form a solid electrical connection. Soldering irons are essential for attaching components to a printed circuit board. By melting solder, you can securely attach wires and components, ensuring a strong electrical connection that is crucial for the circuit to work properly. Fun fact: did you know that soldering is used not just in electronics but also in plumbing, jewelry making, and even stained glass art? It's a very versatile technique. Remember, when using a soldering iron, always make sure to let it heat up fully before starting. Hold it like a pen and touch the tip to the joint where you want to apply the solder. Feed the solder into the joint, not directly onto the tip of the iron, for the best connection. A desoldering pump, sometimes called a solder sucker, is a tool used to remove solder from a circuit board. It works by creating a vacuum to suck up the molten solder, allowing you to clean up connections and remove components. Desoldering pumps are very useful when you need to correct mistakes or remove components from a circuit board. If you've soldered a component in the wrong place or need to replace a part, a desoldering pump makes it easy to remove the solder without damaging the PCB or the components. Fun fact: did you know that desoldering pumps can be used not just for fixing mistakes but also for salvaging components from old electronics? Remember, when using a desoldering pump, timing is key. You need to use the pump quickly after the solder melts to ensure it all gets sucked up properly. A wire is a long, thin piece of conductive material, usually made of copper or aluminum, that allows electricity to flow through it. Wires are used to connect various electrical components together to form a complete circuit. Wires can come in different colors and sizes, often covered in a plastic or rubber insulation to protect them and to prevent electrical shorts. Imagine you're building a simple circuit on a breadboard, like lighting up an LED. You need to connect the power source to the LED and then to a resistor to control the current. Wires are used to make these connections. You insert one end of the wire into the breadboard's power rail and the other end into the row where the LED is connected, completing the circuit. Fun fact: did you know that the color of the insulation on wires often indicates their purpose? For example, red might be used for power, black for ground, and yellow or white for signal connections. Remember, when working with wires, make sure they are properly stripped at the ends to expose the metal conductor. This ensures a good electrical connection. A cable is made up of multiple wires bundled together, often enclosed in a single protective jacket. These wires can transmit electrical signals or power to different parts of an electronic system. Cables come in various sizes and types, depending on their use. They might look like a thick wire, but inside, there are several smaller wires, each insulated from the others. Cables are essential for connecting different parts of an electronic system, especially when you need to transmit more power or multiple signals. They provide a neat and organized way to bundle several wires together, reducing clutter and improving safety. Fun fact: did you know that cables are also used to transmit signals over long distances? For example, undersea cables connect different continents, allowing for global internet and communication networks. Remember, when using cables, ensure they are rated for the power or signals they need to carry. Using the wrong type of cable can result in poor performance or even damage to your equipment. Copper-clad laminate is a material made up of a thin layer of copper that is bonded to a non-conductive base, often made of fiberglass or a similar insulating material. This combination makes it perfect for creating PCBs. Copper-clad laminates are essential for making PCBs, which are the backbone of most electronic devices. The copper layer is used to create the electrical pathways, or traces, that connect different components on the board, while the non-conductive substrate provides support and insulation. Fun fact: did you know that almost every electronic device you use has a PCB inside it? From smartphones to laptops to kitchen appliances, PCBs are everywhere, making the copper-clad laminate a critical material in modern electronics. Remember, when working with copper-clad laminate, it's important to handle it carefully to avoid damaging the copper layer. The etching process should be done in a well-ventilated area and with proper safety equipment. A printed circuit board is a flat board that holds and connects various electronic components. It provides the physical structure for mounting the components and the electrical connections between them through conductive pathways, or traces. Etched from copper sheets laminated onto a non-conductive substrate. The PCB ensures that all these parts are connected properly and can communicate with each other to perform complex tasks. Fun fact: did you know that the first PCBs were developed in the 1940s? Since then, they have become the backbone of virtually all electronic devices, from simple gadgets to advanced computers and smartphones. Remember, working with PCBs requires careful planning and precise execution. Ensuring all components are correctly placed and soldered is essential for the circuit to work as intended. Always handle PCBs with clean hands to avoid contaminating the contacts. Solder is a special type of metal alloy that melts at a relatively low temperature. When it cools and solidifies, it forms a strong, conductive bond between electronic components. This makes it essential for building and repairing electronic circuits. It allows you to attach components securely to a PCB or to connect wires together. The resulting joints are not only strong but also conduct electricity, which is crucial for the circuit to work. Fun fact: did you know that soldering is an ancient technique? It has been used for thousands of years, originally for joining metals in jewelry and metalwork before becoming a key technique in electronics. Remember, when soldering, it's important to work in a well-ventilated area because the fumes can be harmful. Ferric chloride is a chemical compound with the formula FeCl3. It is a dark, crystalline solid that dissolves in water to form a solution. This solution is widely used in the process of etching PCBs. Ferric chloride is extremely useful in the manufacturing of PCBs because it can dissolve copper. When you want to create a PCB, you start with a copper-clad laminate and use ferric chloride to remove the unwanted copper, leaving behind only the desired circuit pattern. Fun fact: did you know that ferric chloride is also used in other industries? It's used in water treatment plants to remove impurities from water and in the production of certain types of dyes and pigments. Remember, always follow safety protocols when using ferric chloride. Proper disposal of used ferric chloride is crucial to avoid environmental contamination. There are other tools, materials, and equipment used in electronics and electrical work. However, the items I discussed are the most common and essential for basic electronics and electrical tasks. Now, let's have a quick self-check. Identify the correct tool, material, or equipment based on the description provided. Feel free to pause the video if you need more time. Number 1. Versatile pliers used for gripping, bending, cutting, and stripping wires. Example use: twisting wires together during electrical installations or repair tasks. The answer is combinational pliers. Number 2. Cutting pliers used for cutting wire and small pins in areas that are hard to reach with larger cutting tools. Example use: cutting excess wire on components soldered to a PCB. The answer is diagonal pliers or side cutter. Number 3. Instruments used to measure voltage, current, and resistance. Example use: troubleshooting circuit boards by measuring voltage drops and continuity. The answer is multimeter. Number 4. A construction base for prototyping electronics without soldering. Example use: testing and prototyping circuit designs before creating a permanent PCB. The answer is breadboard. And number 5. A hand tool used for melting solder to create electrical connections between components. Example use: attaching components to a PCB by heating their leads and pads with a soldering iron and applying solder to secure them. The answer is soldering iron. I am sure that most of you got a perfect score. For those who didn't, you can watch the video again or look for other references to expand your understanding of the specific tools, materials, or equipment. To conclude this video, here is a simple reminder. Remember, having the right tools and knowing how to use them safely is crucial for any project. Whether you're soldering components, measuring electrical properties, or troubleshooting circuits, these basics form the foundation of effective and efficient work. Thank you for watching. Stay safe.